Music connects us. We listen to it, play it and enjoy it. But it can also be very beneficial to your brain and that of people with brain-related issues.
Why does the brain need music? This is the University of the Netherlands.
We all have that one song that takes us straight back to that one summer when we were 16 having fun with our friends. Or to the first date we went on with our partner. Or even to the back seat of our parents' car when going on vacation. Music affects us in a special way, and sound which makes music is as old as time itself. This is the sound of a star, a galaxy. And every star has its own unique sound, which can be traced back to the beginning of our universe. Today, I would like to tell you a little bit why music affects us in such a unique way. In my research, I focus on the ways in which music stimulates the brain and how we can use this influence to help people with all sorts of brain-related issues like autism or Alzheimer's disease. But I will also take you on the journey through the healthy brain. One of the things which makes music so special is that it engages our entire brain. When we look at the brain, when somebody is listening to music, we see that it activates all areas in the front, on the left, the right, even the back, as well as the center and all over. So let us take a closer look at this video where you can see different angles of the same brain. When the music plays, you see all the different areas in the brain light up or get active while listening to the music. You can see high activation in red and low activation in blue, a constant switching between different areas in order to make sense of what you've just heard. Here you can see a more schematic view of this intricate network of brain areas that are active when we only listen to music. Each circle represents a particular brain area, which amounts to a bigger area that we call lobes. The lines between the dots you could see as cables, which are connections that link one area to the other. Taking a closer look at these areas, we see the one in orange, which is your parietal lobe, where among others, sensory information is processed. But also the motor cortex, here in dark blue, is active when listening to music. This area is responsible for movement. In green, we see the temporal lobe, associated with sound perception, as well as the amygdala with its fight and flight response, the hippocampus, which is associated with memory, and the brainstem with all its vital functions as linked to the body. Last but not least, the frontal lobe, here in red, with all its executive functions, such as, for example, planning, working memory, or even attention. We all use those executive functions in our everyday lives. Some can of course plan better than others or can focus easier on a certain task, but overall we all have and use those executive functions. Unless there is a certain neurological or cognitive problem. Often people with, for example, autism or Alzheimer's have difficulties in using these functions properly. Sometimes these functions do not work at all. And regardless of how they are used, we can see any change in these functions translate into different behaviors than we would otherwise expect in healthy people. But I will come to this one later. Let us start at the very beginning. We already have witnessed the very early sound of music which stimulates our brains. But it can also stimulate the development of the brain. For example, music can have a very strong positive effect on babies who are born preterm. As you probably know, most babies are born at about 40 weeks of pregnancy. But some babies are born early, weeks or even months too early. This can cause health problems, such as the organs not being fully grown yet, or some cannot breathe for themselves or even digest food properly. Moreover, the brains are not quite ready to take in the whole world in these crucial early years. This picture shows how the brain develops during pregnancy. As the brain grows, you will see an increase in folds or wrinkles, which we call gyri and sulci. These countless folds allow humans to pack in more grey and white matter into their heads, which in turn can mean more advanced brains with increased cognitive abilities. You can imagine that if a baby is born preterm, the brain does not properly work yet. This image shows a different brain activity at 27 weeks and at 40 weeks. At 27 weeks, the brain has not yet created all of its connections, so it fires randomly to establish the connections between different brain areas. Therefore, individual cells that make the brain are firing and then stopping again. At about 40 weeks, the brain is more mature, and thus activity is more regular. So how can music help to support the development of those preterm babies who might be 27 weeks or even younger? Research suggests that music can help with the creation of connections in the brain. It will always try to make new connections or will try to make existing connections even stronger. In short, the more connections or different connections there are, the better you are in performing a certain task, like for example the earlier mentioned executive functions. So music can improve these executive functions because there is not one brain area which produces music in the brain, as you will remember from the schematic representation earlier. Music hijacks different areas and as a byproduct makes them stronger. Relating this to our preterm babies, we can use music not only to help strengthening their existing connections in the brain, but also help them to calm down, to lower the heart rate. Preterm-born babies will always spend some time in an incubator, which is in a hospital at the intensive care unit. Such a unit can be a very stressful environment with different beeping sounds or other hissing noises from machines which are completely new to the baby brain. Music can help to reduce these stress levels, lower the blood pressure and, as I said, the heart rate as well, and therefore calm down the child and somewhat distract it from the strange noises as it would have heard music through the mother's or father's singing before. You might now wonder what kind of music does a specially trained music therapist have to play. And no, not of course a complete symphony by Beethoven or Beyoncé's latest hits, as nice as they are. But it all starts with one chord on the guitar or a soft sung melody of only a couple of tones, which will be played or sung live next to the incubator. Ti 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 ti. While playing the music, we can actually see the child turning towards the music. Then the parents who are standing next to the incubator start singing as well, and we see the child turning from the music therapist to the parents, and then back again to the music therapist. While this happens, the child's heart rate is lowering and the child calms down. Here, music can help the developing brain. But as I have told you, music can also help people with brains that function differently to so-called healthy brains. Because music stimulates all areas of the brain, it can help people to overcome a certain limitation, which are caused usually by damage or belated development. Take people with autism spectrum disorders, for example. Here you can see the brain activity of an 11-year-old boy with autism as compared to an 11-year-old boy who does not have autism. We see that the amount of connections in the brain is different. The boy with a form of autism shows less connections in the brain as they have not developed quite yet and sometimes never fully will. Less connections in the brain can mean that the way we behave or solve problems is different as compared to people with more connections. For a lot of people with autism, the part of the brain that processes language does not work as it should. As a result, speech becomes difficult to sometimes even impossible. In light of this, I would like to zoom into one certain brain area called Broca's area. Broca's is the speech production center of the brain, and together with areas around it and with a lot of other areas, it helps us to produce speech. On the left, you see the brain of a person with autism, and on the right, a person without autism. As you can see, the area that is called Broca's, represented here in green and blue, is developed in a similar way, meaning it is present. So technically speaking, there should be no problem whatsoever with speech. And yet there is one. When reading a story to both the person with and without autism, there is activation in Broca's area in the person without autism and hardly any to no activation in Broca's in the person with autism. However, if you take the exact same story we have read to the two persons and we sing it to them, we can see activation in Broca's in the person with autism and hardly any in the person without autism. As we will remember, music stimulates all areas of the brain and thus bypasses damaged or differently developed areas. In this case, music will find another way to stimulate the speech areas, as it uses all the other active areas to allow the person with autism to sing the story. But music's ability to stimulate the brain does not stop here. Do you still remember that song we talked about at the beginning? The one that takes you right back to 10, 20 or even 30 years ago. What else do you remember recalling the song? Maybe you were at the beach, remembering the salty taste of the sea and the cold wind that has been caressing your face. This is called associative memory. Music calls on your associative memory in a particularly powerful way because it triggers all brain areas and networks, so you can also recall a memory, an emotion, or even a feeling. This associative attribute of music can help to stimulate cognition and behavior in persons with, for example, Alzheimer's disease. People with Alzheimer's struggle with accessing the memories and using large parts of the brains. As we can see here, the brains actually shrink in size, therefore losing a lot of their connections and firing power. This results in limitations in using the brain to its full potential. But when playing music, and this accounts mainly for people suffering from Alzheimer's disease, which is just one form of dementia, there is one part in the brain that is seemingly not touched by the disease, the supplementary motor area. This area, among other functions, has a direct link from, for example, moving your fingers over the keyboard of a piano to the part of the brain that is called the hippocampus, where it accesses all sorts of memories as well as those related to music. Once this is triggered, the other still functioning brain areas are activated through the music and all different networks stimulated, resulting in an unlikely behavior. The following will show an elderly woman with severe Alzheimer's disease. She could not remember where she lived and even sometimes her name. But once she sat in front of the piano, something astonishing has happened. By listening to or playing music, people with Alzheimer's can access memories they would otherwise struggle to access. And because of the associations with a particular music, they can remember the sights, smells, and other sensations that went along with that music. Music stimulates the brain through different associations, allows them to recall a particular memory, like playing the piano, for example, or even the last time they have danced with their sweetheart at the first college ball when they were 18 years old. It is truly amazing what music can do for people who suffer from certain brain-related problems. But music is not just helpful for people who suffer from disease. It can also help the healthy brain. Take, for example, how music can regulate our emotions. As humans, we know very well which music to play when we are sad to become even more sad. Music can connect us while listening to the same artist during a concert, giving us a sense of community, triggering emotions and memories. Music seems to be an interwoven part of our being. It makes us who we are, who we want to be, and how we want to perceive by and interact with others. It is truly multidisciplinary and personal at the same time. When we talk about this, it is important to realize that we should not discriminate against music. Every genre has its beauty, and challenging your brain with different forms of music will benefit you in the long run. So stop listening to the same music every day and see whether you can find something that you would never dream of listening to. Find your unlikely ally. We started this lecture with the question, why does the brain need music? We have learned that music will help you make new connections in the brain. It will challenge existing links already made and strengthen them, or even help you learn something completely new. The more different things you listen to, the more your brain will learn and translate this into other abilities like the mentioned executive functions. So whether you have a healthy brain, a sister or brother with autism, or a grandparent with Alzheimer's disease, go out there and listen. Listen alone or together. Be curious and maybe even learn to play an instrument. It is never too late. Thank you for your attention.